Alright, in this video we're going to start by looking at what's known as the vertex formula for a quadratic function. Okay, so if I have a parabola like this and we want to locate this turnaround point, right, this vertex point, and I'll label its coordinates xv and yv, v for vertex, we can compute the location using following formula, right? So if f of x has its equation as ax squared plus bx plus c, then to find the x-coordinate of the vertex, xv, you just take the opposite of b, where b is the coefficient of x, and divide that by 2a, where a is the coefficient of x squared, and then find the y-coordinate of the vertex. Okay, what I'm saying here is you just take whatever this xv value is and plug that into your function, and then that corresponding y output value is the y coordinate of the vertex. And so to illustrate, let's look at problem 9 on the worksheet. Part A says y equals negative x squared plus 6x minus 4. Okay, so to start, I'm going to just identify a, b, and c for this quadratic. So here a is negative 1, b is 6, and c is negative 4. All right, so the x-coordinate of the vertex then, which is the opposite of b over 2a, this is the opposite of 6, that's our b value, and then I'm going to divide by 2 times a, and a is negative 1. And so this simplifies to negative 6 over negative 2, and that is equal to 3. Okay, so what I'm now going to do to find the y-coordinate of the vertex is just plug in 3 in for x into our equation for the parabola. Okay, so I'm going to plug 3 in here for x, so there and there. And let's go ahead and simplify. So I'm going to get 3 squared here is 9, and there's this negative in front, so I have negative 9. And then 6 times 3 is 18, so plus 18, and then I'm subtracting 4. And negative 9 plus 18 is positive 9, and 9 minus 4 is 5. And so 5 then is the y-coordinate of the vertex. So putting that all together, our vertex is located at the point 3, 5. All right, and now to illustrate that this is in fact doing what we want it to be doing, here is a graph. This is just on a Desmos. And so y equals negative x squared plus 6x minus 4. Yep, that's our parabola. Notice this is a parabola opening down here because the coefficient of x squared in this case is a negative. And so we're looking for this turnaround point, right? This vertex location. And I see we're located at 3, 5. That's exactly what we found. All right, cool, it's working. How about part B? We have f of x is equal to 2x squared plus 3. So notice here I have the squared term, right? I have this 2x squared, and then I have this constant term, the 3, but I don't have a linear term like I had in part A. Now, I can write this expression as 2x squared plus 0x plus 3, just for emphasis, because here what we're really saying is, well, a is 2, b here is 0, and c is 3. Okay, so now to find the vertex, we can proceed just as we did, right? Just using the vertex formula, so opposite of b over 2a. You see now I'm going to be taking the opposite of 0, which of course is just 0. And so when all is said and done, this is just going to equal 0 because I'm going to get 0 in the numerator and 4 in the denominator. 0 divided by 4 is, well, 0. Okay, so now to find the y-coordinate of the vertex, we're just going to take this 0 and we're going to plug it in to the rule for f. Okay, so I have 2 times the input squared plus 3. So go ahead and input 0. And this is going to give us just 0 plus 3, which is 3. All right, so that is the y-coordinate of the vertex. And so here we conclude that the vertex is at the point 0, 3. All right, well, let's go and check that one real quick. So here we have f of x equal to 2x squared plus 3. So bring up the graph in red. Now this is a parabola opening up. And notice the coefficient of x squared is a positive number now. All right, and we're looking for this turnaround point, this vertex. And here it is, 0, 3. So again, this is doing the job. All right, well, that's going to do it for this video. Thanks.